Okay, so yeah, hello, I'm Arat Genoa. I work in CIDETEC, which is a research institute in the Basque Country in the north of Spain. And today, together with Brigitte from Podcomp, we will be presenting what we have been doing in the BIO-UPTAKE project using reversible prepregs for the manufacture of a recyclable bathroom ceiling. So this is the outline of our presentation. First, we will go and see which is the manufacturing process to obtain these bio-based 3R prepregs. We will move on to the concept of enduring prepregs or enduring bio-based prepregs. In this case, we will see the processes that can be used for processing these kind of materials. And then Brigitte will explain us how they have used this material to manufacture the bathroom ceilings. So a prepreg material is a reinforced a prepreg is composed by a reinforcing fabric, usually carbon fiber or glass fiber, which is pre-impregnated with a resin system. So in the fabrication process, the fiber or the fabric goes through a doctor blade where it's impregnated, and then it enters the first compaction roll. And when it comes out of here, together with the inferior release films, it continues the way through the ovens where a temperature can be applied to the second compaction roll. Here, as the superior release film is also added, and finally we get we wind the material to obtain a prepreg roll. So in this case, well, here we can see a video of this process where that is more clear than what I have just explained. So in the BIO-UPTAKE project, what we have done has been manufacture this kind of prepregs, but using bio-based materials. For the resin, we used a bio-based epoxy resin that was supplied by specific polymers. And we have used to formulate a 3R epoxy system, which is recyclable, reprocessable, and repairable. Using this epoxy system, we have impregnated flax fiber, and we have obtained the prepreg rolls that we were looking for. In this table, we can see the properties of the dynamic network that are very similar to what we could obtain if we used a common Dejeva resin instead of using a specific polymers one. So here the impregnated fibers go through. It's sorry for the quality of the video; it's not very good, but yeah, they go through the whole process, and then they come out, and we collect it here in a roll. So as I said, what we are using here is a bio-based, in this case, 3R dynamic resin. So the advantage this kind of resin has or have is that unlike conventional epoxy resins, which are non-reprocessable, non-repairable, and non-recyclable, the dynamic epoxy resins, thanks to the dynamic or reversible disulfide bonds, aromatic disulfide bonds that have in their structure, are able to or offer the possibility of being reprocessed, repaired, and recycled even after curing. This is a technology that was patented by CIDETEC some years ago, and is what we are applying here. Using this kind of resins in the manufacturing of prepreg materials gives an advantage, and is that the prepregs can be made like what we call enduring prepregs. So a regular prepreg is usually stored in the form of rolls, and it's necessary to do it in the freezer because they need to be kept in a tacky stage to be used afterwards. But when we have enduring prepregs, the manufacturing process, as we saw, is the same, but they can be, in addition to being stored as rolls, they can also be stored as flat laminates, as we can do it with thermoplastic organosheets. So we can store them at TG that can be adjusted on demand, and these laminates or rolls can be used at room temperature and thermoform to obtain the desired parts through pressure molding. So if we apply pressure and temperature to a semi-cured prepregs or to these enduring prepregs, we obtain a multi-layer composition. Unlike this, so in the image above, we see the enduring prepreg. I mean, we have different flat laminates. We put them together, and with pressure and temperature, we obtain a multi-layer material. But if we do so with a common regular prepreg, we don't get this addition between layers. So which are the advantages of the enduring prepregs? That they can be stored at room temperature for years without losing the reprocessability, and thus the storage is much more cheap than that of the traditional prepregs. This is also an advantage for the shipment because it doesn't need to be shipped in a frozen stage, and the costs are much cheaper. Sorry. And finally, the compression forming of procured materials is possible, and it just takes some minutes to obtain a high performance, well consolidated part. So in the end, they can behave like thermoplastic organosheets. So this gives an advantage at the moment of processing them. Different processes can be used for doing so. We can do it by vacuum back processing and curing. We can use a hot press for the curing and the multi-layer formation. It can also be done by vacuum thermoforming, or we can also do the thermoforming directly on the hot press. So now we will see how Birgitta at Podcomp has used these materials.
Hello, everybody. My name is Birgitta Nyström, Sustainability Coordinator at Podcomp. Podcomp is a composite manufacturing company with our main product being a prefabricated bathroom. And at Podcomp, we strive continuously to reduce environmental impact from both our products and our processes. Okay, next slide. So the current solution is made from unsaturated polyester, glass fiber, and a PET foam core sandwich. That is what the whole bathroom is built from, floor, walls, and ceiling. And the panels are produced by vacuum infusion. They have a chipboard with a white polypropylene film as the visible part inside the bathroom, and it's glued to the sandwich with a non-bio-based glue. The BIO-UPTAKE solution that we have worked on together with our partners is the 3R prepreg, which it contains flex fibers and bio-based epoxy. And we use a balsa core to produce a sandwich to replace the ceiling of this bathroom, and we produce it with a double vacuum process, and it has the same chipboard glued with reversible adhesive. Next slide. Current production is vacuum infusion. It works well, but we have a lot of auxiliary materials, one-time use materials, a lot of manual control, and quite labor-intensive production. Next slide. Next slide. Can you
vacuum process?
Can you change? Hello.
I changed.
No.
Hi.
It's
Can you hear me?
One too many. Okay. Well, this is a messy picture.
You see, I can double back.
Now you see the bio-uptake double vacuum prepreg processing. Is that what you see? Hello?
Yes.
Yeah. So in this, the process that we have developed in the bio-uptake project is double vacuum prepreg processing. Auxiliary materials are reduced. The loading of materials is still manual, but the process is completely automated and less labor intensive. So the final slide. Yeah, these are images of the sealing demos that will be mounted in the shower area of our staff changing rooms for long-term durability testing in real conditions. And the chipboard is glued with a reversible adhesive and can eventually be separated from the sealing. So the left image is with the white polypropylene film shown, and the balsa core and the prepreg on top. And the right hand picture is the sandwich backside, which will not show in the bathroom. Okay, that's all from me. Thank you.